Hello, welcome back to Mastering Statistics. This will be our last problem in Anova. We have the number of calls that each shift of a call center receives on a given day. We've sampled 7 days for the morning shift, the afternoon shift, the night shift. These could be warranty calls or complaints or whatever. In the morning shift, one day we looked and they got 2 calls, then 3 calls another day, 2 calls another day, and so on. The afternoon shift looks like to me gets a little bit more calls than the morning shift. And the night shift, we have different data there. A manager thinks the number of calls that each shift receives is different. So we want to see if it's different by doing an Anova test to see at the 0.01 level of significance and test the claim. So 0.01 level of significance means we're doing 99% level of confidence. So we want to know with really high certainty if all of these shifts are really getting the same amount of calls or not. And not just of the data that we've collected, we're talking about globally, all the time, past, present, and future, is the morning shift, the afternoon shift, and the night shift getting on average the same number of calls. So the null hypothesis will be that yes, they are getting the same amount of calls. Our test will tell us if we're rejecting that hypothesis or not. So we go ahead and highlight our data. We go to Data Analysis under the Data tab, Anova Single Factor, and we have to select our data by dragging and highlighting there. And we go ahead and collect the column headings there. And everything's organized by columns. Now we have to make sure and change alpha because before we were doing 0.1, now we're doing 0.01 level of significance. Labels are in the first row, and we hit OK. Another sheet pops up. Let's go ahead and zoom in so we can see what we're doing, 140. And let me drag these tables out a little bit. Okay. First of all, what the calculations are showing us is that the morning shift has an average number of calls over the data that we've collected. So this is the sample mean, 2.57 calls. The afternoon shift looks like it has on average more, 3.71. And the night shift has even more on average, 4.28. And it gives you the variances of the sample data that was collected there. So really all you have to do for the bottom line here in the Anova test is compare F to F crit. Right? So F in this case, the test statistic is 3.9, and F crit, which is F alpha, the bench or the hurdle, is 6.01. So at this level of significance, this test statistic is to the left of F crit. It's nowhere close to F crit. That means we fail to reject the null hypothesis. Fail to reject null hypothesis. So this is a really good example of how it all depends on how the problem is framed. Because when you go back to the original data, the null hypothesis, remember, is that all 3 of these guys are getting the same number of calls on average, globally, on their population. We only sampled 7 days here, but on average, everybody's getting the same thing. And it looks like the afternoon shift and the night shift are getting a lot more calls than the morning shift. But at this level of significance, we're failing to reject that null hypothesis. That means we're saying the null hypothesis is actually true, that all 3 of these are actually getting the same amount of calls. Even though clearly it looks like the morning shift is getting fewer calls than the afternoon and the evening shift, the problem with it is we only have 7 samples. It's not enough data. It's not strong enough. It's not that it's basically impossible that it's true, but we're just saying it's not strong enough to reject that null hypothesis. And part of the reason it's not strong enough is because we've done it at a 99% level of confidence. So all you can really say is that with a 99% level of confidence or 0.01 level of significance, we fail to reject. So we're saying that all 3 of these are getting on average the same number of calls. And you